Okay, so I'm going to go through another example of a tutorial-style proof problem. And remember, the point of these is not to get you ready for how every single proof is going to look step by step. This is just to get you used to the idea of the flow of a proof. In other words, the steps that you may use from time to time as you're going through a proof, and how that process should look, what sorts of things you can do in one step, and what sorts of things you maybe should explain a little more and do those in 2 or 3 steps. So in this example, we're saying, starting off, some general directions, work on one side at a time, never both sides. Okay, we never work on both sides of a proof at once. And whichever side looks ugly, I'd say start with that. Okay, it's easy to take something that's complicated like this thing and turn it into something simple. Once you get the idea under your belt anyway, it's easy. But I will tell you, it's very difficult to take something simple and turn it into something else that's complex, because there are a lot of different ways to make something more difficult, but there's usually not so many ways to make something simpler. Okay, so we start with this one by saying, let's see, what do we want here? Foil the 2 parentheses on top. Okay, now by foiling I just mean distribute the multiplication. So what do we get here? This is going to be 1 times 1 plus 1 times cosine. And then we have a negative cosine times 1 right here. So that's going to be negative cosine x. And then a negative cosine times cosine. So that's going to be a cosine squared of x. And it says combine like terms. So let's go ahead and combine like terms. Let's see what we get here. Cosine minus cosine, that cancels out. So all we get is 1 minus cosine squared x. Now that's on the top. On the bottom, we still have cosine squared x. Okay, so this would be what we put in here. Now, next step, we're going to use the Pythagorean identity to rewrite the top of the fraction. And I want to point out we're only doing the top of the fraction according to the directions. Rewrite the top of the fraction in terms of sign. So what is that Pythagorean identity? Well, my favorite Pythagorean identity is the Santa Claus one, because we use it so much. Sine squared plus cosine squared equals 1. Well, that's the same as saying this. Cosine squared equals 1 minus sine squared, right? Same thing. So let's take the previous answer and rewrite it now. 1 minus, instead of cosine squared, I'm going to have 1 minus sine squared. Okay, oh, hold on. I'm using x's in this example, so we'll just keep doing that. Okay, and that's all over cosine squared x. Okay, and it wanted us to combine like terms. So this isn't actually my final answer yet. Let me just make a little room over here. I'm going to take this and move it over. Okay, that was my scrub work. And let's simplify that a little bit. If you look at 1 minus 1, well, that's just 0. And then you say minus times minus sine squared, that's going to be sine squared. So we simplified the top by combining like terms, it's just sine squared. On the bottom, you still have just cosine squared. We haven't been told to do anything with that. And now in this last step, you say, let's use the quotient identity to rewrite in terms of tan. Well, what's the quotient identity? Tangent equals sine over cosine. There's another quotient identity that says cotangent equals cosine over sine. I hope it's obvious which one we should use, right? Let's use the sine over cosine version of this. So if tangent is sine over cosine, then sine squared over cosine squared, that's just going to be tangent squared of x. And now we're done. That completes the proof.